Okay, so here's section 2-5, using proofs in algebra. Proofs are just a way of showing someone who's looking at your proof that your answer is correct. Don't forget to write down the section title so I can see it when I'm looking at your notes. Remember, throughout this whole lesson, you can stop and pause and rewind as much as you need to. I'm going to go at a little bit of a fast pace, but you just pause whenever you need to. Okay, we have these rules that you already know. You're already familiar with them, but we're going to be using them in a new way like you haven't used them in the past. The addition property says that if you have two sides of an equation that are equal, then you are allowed to add the same thing to both sides and it will still be equal. So you could say A plus C equals B plus C, and it would still be true. It would still be balanced. So what do you think would happen for the subtraction property? If you're starting off with two things that are equal, A equals B, then you are allowed to subtract the same thing from both sides. So you could say A minus C equals B minus C. Take the same thing away from both sides. Multiplication property says if A equals B, then you are allowed to multiply both sides by the same thing. A times C equals B times C. And likewise the division property. A equals B, if that's true to begin with, then you're allowed to divide both sides by C. A divided by C equals B divided by C, as long as C does not equal 0, because that would make it undefined for a fraction. The distributive property, you will recognize this one for sure. A times parentheses B plus C. You're allowed to take that A and multiply it by everything inside the parentheses, so it looks like A times B plus A times C. The A gets multiplied by everything that was on the inside. Okay, pause if you need to and go back and fill these boxes in. The next part of our notes talks about some new ones that you might not have heard of before, although they should be kind of familiar to you. Reflexive property means that it is exactly equal to itself. For example, A equals A. Whatever's on this side has to be exactly the same as what's on that side. It's like they're looking in the mirror again. The equal sign is the mirror, and they're exactly the same. So you can have this for equality, and you can have it for the congruent sign as well. For equality, we could say something like this. Segment MN equals itself, MN. And for congruence, you could say EF. Notice there's a bar on top whenever you use the congruent sign. EF is congruent to segment EF. Okay, so both sides match perfectly. It's the same thing on both sides. Symmetric property means you can turn it around and it's still going to be equal. It's like the lines of symmetry that we did on the on chapter 12. If A equals B, that's the exact same thing as saying that B equals A. Okay, so we're dealing with segments and angles, so let's look at this one. These are two segments. If JK equals RS, then you can flip it around. RS equals JK. That is going to be the symmetric property. It requires two separate equations where one's forward and one's backwards. Congruence will be similar except that they use a congruent sign instead of an equal sign. If angle 1 is congruent to angle 2, then you're allowed to say that angle 2 could be congruent to angle 1. Just flipped around. Two separate equations just turned around. The transitive property is different, probably brand new to you. If A is congruent to B and B is congruent to C, if that's the case right there, then you're allowed to cut out the middle that's exactly the same. And what do you think you would end up saying? A is equal to what in the end? C. If they're both equal to B, if they're both equal to the same thing, then they're equal to each other. If A equals B and B equals C, then A equals C. So look at this one. If you have these two things, if EF equals GH and GH equals IJ, pause if you need to write that down, then think about what could be happening here. Which or what would be equal to each other in this case? You can cross out the middleman, GH, and you can just say that EF ends up being equal to IJ. They're both equal to the same thing that makes them equal to each other. And likewise for this one. If PQ is congruent to RS and RS is congruent to TU, if RS is congruent to both of these things, then which two things can you also say are equal to each other? You can cut out the middleman. RS and RS, you get rid of it, and what you're left with is PQ is congruent to TU. And it looks like that. And the last one you need to know for today is the substitution property. Those of you that are into sports, you do substitutions all the time. But the thing is, you take out one position and you fill it with the same position. You don't take out a guard on the basketball field and replace it with a forward. You have to replace it with another guard. So the two things have to start out to be equal to each other or equivalent. If A is equal to B, then A may replace B at any time. Vice versa, B can replace A. Because they're equal to each other, they're equivalent, they mean the same thing. So for instance, if you know that WV equals XY, and you know that WV plus 6 equals 10, that's given to you, you could take out the WV and replace it with what? XY. Since WV and XY are equal to each other, they are interchangeable. WV can be replaced with XY, XY can be replaced with WV at any time. And you've done that in algebra, a lot of it. But over here for the congruent sign, it doesn't work. You're only allowed to do substitution with an equal sign, not with congruent signs. With these other three, you can do it with congruence. Okay, pause if you need to, copy these things down. Okay, so just watch these examples first. I want you to get an idea of what's going on with how we're turning this into a proof. This is an equation you're used to seeing. 2x plus 3 equals 9. And then what would you do on both sides? You would subtract 3 from both sides, right? If you were going to be solving it. Minus 3 and minus 3. Okay, now think about what you just did. You just subtracted. You know how to do that. No problem. Look at number 2. 2x equals 6. What would you do to both sides to get this result? You would divide by 2 so that you could have x by itself. Alright, so let's put that into a proof form now. This first equation was given to you as the problem that you were supposed to solve, so that was given information. But number 2, you have to write down the reason of how you got from here to here. And what we did was we subtracted 3 from both sides. Okay, that would be the subtraction property that we had on the front page. You're allowed to subtract the same thing from both sides. And how do we get from step 2 down to step 3? We divided both sides by 2. So think in your mind, what rule, what property would you use for that one? It would be division property. Okay, and that's how simple it is. You just write down as a reason what you already did over here. So let's watch one more. Try to keep it in your mind before I go over the answer. Number 1 is always your, well, not always, 90% of the time, it's your given problem. But number 2 is, how did we go from here to here? Look, 9x didn't change, minus 5 didn't change, 3x changed. 3x and 5x went together to form 8x. 6 and 2 went together to form 8. So we call that, from algebra, we call it combining like terms, and that's what we did. We combined like terms. You're always looking for what changed, what happened from this step to the next step, so that you can explain what happened. 9x minus 5 equals 8x plus 8. The 9x changed into x. Think in your mind, how did that happen? Well, it happened by subtracting 8x from both sides. Minus 8x here, so that could cancel. And then minus 8x over here. So what you're left with is 9x minus 8x leaves you with x. What property made that happen? You subtracted. You subtracted 8x from both sides, so it was the subtraction property. And the last one, to go from our new result here down to this step, think in your mind, what are you doing on both sides? You should be adding 5. Add 5 here and think about what property that means as I'm writing it. Minus 5 means you do the opposite, which is plus 5 and plus 5. You end up with 8 plus 5 equals 13. So what did you do? You added the same thing to both sides. You used the addition property. Okay, so that's how those can work.